How'd you like to listen to .NET Rocks with no ads? Easy. Become a patron. For just $5 a month, you get access to a private RSS feed where all the shows have no ads. $20 a month will get you that and a special .NET Rocks patron mug. Sign up now at patreon.netrocks.com.
Hey, Porto! It's .NET Rocks!
All right.
Holy crap.
This is a great room.
It's a
for a
great,
lot of echo.
yes,
So
a great room.
certainly filled the space
Quality
up.
is determined by level of volume.
Yeah.
Absolutely. The blast radius.
There you go.
Right?
Hey,
So,
we're back in Portugal.
We are back in Portugal.
It's great to be here.
I love Porto. I love Portugal. I was in the middle of town, and I came across a restaurant, and the sign said Churrascaria, which means grill, right? De Infante. I didn't know you guys ate babies over here. So, no,
No,
not funny.
maybe you translated it wrong.
Too soon?
Yeah, that's all.
Do Infante. I guess Infante is the name of the
Twins.
area,
Yeah,
2 babies.
but it looked like we eat our babies well done
nice.
on a skewer.
I think it was W.C. Fields said it was all about the sauce.
Yeah, yes.
I love children. A
Yeah.
little bit of salt, a little bit of pepper.
Got it.
Exactly.
You got it. Oh, we're going to have some fun today.
We are going to have some fun, but first we have this little thing called Better Know Framework. Roll that crazy music.
All right, buddy, what do you got?
Well, I've been waiting for this one because it happened a while ago, but if you don't know, I have a consultancy called AppVNext, and we are the shepherds of an open source project called Poly. Anybody use Poly? How
Wow,
about
lots of hands.
how about a clap of hands? Use Poly.
Lots of things.
Well, Reverend Billy just walked in the room. Well, Poly just did just came out with a major update, version 8, and believe it or not, it started with the .NET team, because the .NET team was basically looking at the source code and said, "Hey, we think we can improve the performance and the resource usage of Poly, but it's going to require some new interfaces and almost a complete rewrite." And so the rest of us said, "Yeah."
Yeah, I'm
sure.
sorry. Did the .NET team call you
Yeah.
and say they want to make your project better?
Yeah, I mean, what do you say? Nah. So it took a lot of meetings and a lot of understanding. And basically what they were able to do is, without you having to change any of your code that uses Poly, you will get the benefits of the new performance and resource allocation that's under the hood. But if you want to use the new models and the paradigms and the interfaces, you can do that.
Oh,
So
interesting.
Greenfield, you can go forward
With a new style.
with a new style, but just if you use Poly in place, I'm not sure if it's completely compatible or you have to change some class to some other class, but it's pretty much a simple
Cool.
a simple fix.
And I have been emailing with Joel Hewlin to schedule a Poly show for .NET Rock.
Yes, we definitely
So we'll
want
get
to
that
do
figured out. That's cool, man.
So that's what I got.
Awesome.
Who's talking to us, Richard?
Gravity Comment off of show 1860, the one we did with Jeremy Miller back in the summer of 23, talking about minimal architecture, because Jeremy likes to cause trouble, goodness knows. And this comment comes from Trevor, who says, "I love this discussion. Enjoyed the comments on microservices versus monoliths," which is actually a reference to an earlier show we did with Layla Porter.
We've been following this trend of people sort of
Pushing back on
microservices.
Yeah. I got pushed heavily into microservices approaches with a product that we built and re-architected into microservices, and it was the worst mistake ever. Things just became more complex. It was harder to maintain. It added a bunch of latency and security issues, and the complexity was just not worth it. And so I came up with a new acronym for appropriately sized service.
Or
Nice. I can relate. This is a good one. I 100% believe in services, separation of concerns, and clean architectures. But the approach must be appropriate to the complexity of the solution and the size of the team.
Yeah.
It makes no sense to have 100 separate services for a team of 10 people, but then it also makes no sense to have a massive single deployment with a code base and a team of 250 people. The services need to work with the cognitive load and be appropriate to the organization and team structures. And I was loving the discussion on all of this, except for that one point. Stop making the CTO out to be the bad guy. Love from Trevor, CTO.
That's great.
Yep, that's fair.
Yeah.
I definitely think we need a whole show on ass.
I think so.
Yeah, seems obvious.
Yeah.
So, Trevor, thank you so much for your comment, and a copy of Music to Go By is on its way to you. And if you'd like a copy of Music to Go By, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there. And if you comment there and I read it on the show, we'll send you a copy of Music to Go.
And you can also follow us on Twitter if you want to, but the real cool kids are over on Mastodon. I'm at Carl Franklin at techhub.social.
And I'm Rich Campbell at Mastodon.social.
Send us a toot. We'll get around to reading it.
Read them all.
We read them all.
Publish them.
And with that, let us introduce Charity Majors to the show. Charity is an ops engineer and CTO at honeycomb.io. Before that, she worked at Parse, Facebook, and Linden Lab on operations and developer tools, and always seemed to wind up running the databases.
That's because that's where all the problems were.
Yeah, you stand next to the database, you're going to be running it.
It's
You're the next.
contagious.
Yeah, he
Yeah.
catches.
Also co-author of O'Reilly's Database Reliability Engineering and the newly released Observability Engineering. Charity loves free speech, free software, and single malt scotch. And
Nice.
Who could blame her? Give her a round of applause. Charity Majors.
Okay. Well, I guess we got to start at the beginning, right?
Start at the beginning.
What the heck is observability engineering?
So that's a great question.
Is this like the engineering of Windows?
Yeah, kind of. I mean, observability comes from controls theory, right? And it's like, how well can you understand what's going on inside your systems just by observing the outputs? And
You press the button, the light turns on.
yeah, exactly. And you know, I for years was like really religious about trying to define it in a very specific way, and I should have won, but I lost. So
You were outnumbered.
I was outnumbered. Thank you. So I mean, it's come to just kind of be a generic synonym for telemetry, which is what it is. But when we were trying to figure out how to talk about what I think of as just kind of the next generation of telemetry, it's kind of distinguished from the last generation of telemetry, obviously, which was very much focused around the metric, right?
Mhm.
Which is just a number with some tags appended. Doesn't handle high cardinality, doesn't handle dimensionality, doesn't handle. It's super fast, super powerful.
Now you drop some OLAP terms into there. Cardinality and indexability. Like,
It's funny for a database person to drop OLAP things. But you're talking about just any way that you can really observe the state, the internal state, not necessarily what it's doing onto the outside.
It's about observing the internal state and being able to explore it, right? Not having to decide in advance, here's the data I'm going to collect, because here's the questions I'm going to need to answer, here's my dashboard.
Yeah.
You know, it's about being able to go to combine your questions, to ask, because like anything that you're trying to understand these days is going to be a very complicated answer for the most part. It's like, okay, these errors are spiking, but only for users that are running this version of Android with this particular firmware in this region, this language pack, with each of those is a high cardinality dimension. And if you don't capture the data in a way that preserves all that context, you can't ask new questions.
Do you have some examples of how observability has improved a project in particular?
Sure. I mean, I think of it as really, it's kind of where development meets operations, right? Like, I feel like big picture, you know, in the beginning, there were engineers who wrote code and they owned it in production. Right? And then everything got super complicated and we're like, there's too much. So some of us are going to write code and some of us are going to understand it. And that was not that was not a great idea. And so like, we're kind of like reunifying the streams now. I think every engineer should be writing their code and owning it in production. Everyone who's a specialist in operations should be also like opening the door and looking under the hood and understanding the code, right? There's specialization is great, but ultimately, you know, our systems have gotten so complex that you have to write it and understand it.
I feel like you got to dig into that own it in production, because it's not like they're also going to be sysadmins. So
Exactly.
as they are responsible for the...
You're responsible for your systems, right? You wrote it. You own it. You unleashed this horror upon the world. I mean, I feel like there are these feedback loops at the heart of engineering.
Sure.
Some of them are like code review, right? Some of them are like deploys. But like, if you don't hook up the feedback loop, if you aren't being exposed to the consequence of what you're doing, then like you don't actually know if your code is good or not.
Well, I think there's a great point there as a developer then, that if my telemetry just tells me how many times my code was hit, that doesn't necessarily give me anything to do.
And this is where I feel like operations folks have had a harder time embracing observability in some ways than software engineers have, because with ops people, it's like we learned how to debug, but it looked like this. I've got a dashboard. Something's wrong, so I'm going to start paging through dashboards and looking for similar spikes, just like pattern matching with my eyeballs. Like,
Right.
oh, it looks like it's Redis, and you get it's great because you get this hero journey where you just jump to the end
Right.
and you understand what's going on because you're in this shit all day, every
Right.
day. Nobody else does. They're like, whoa, how'd you do that?
Yeah.
Right.
And all I did was reset the Redis service and problems went away.
Right? But like, that's not debugging.
Right.
Pattern matching with your eyeballs is not debugging.
Sure.
Debugging looks like you take a step, you ask a question, you look at the answer. Based on the answer, you take another step. It's like following a trail of breadcrumbs. You don't know what the answer looks like until you get there.
Can we talk about some of the new modern observability tools that we might think about using to replace the tools that we're currently using?
Yeah, I mean, I think in big picture, it has to be based. It can't just be based on the metric, because the
Right.
number, you've discarded all that.
You're looking at
context.
the output, basically.
Exactly. It has to be based on arbitrarily wide structured data blobs, which now look like spans, right? Those are just like wide events structured, which you can trace because there's been a number that's appended to it. That's what you need in order to understand your telemetry in production.
Because I can imagine at a peak load, like we think about a metric that shows, this is when we're posting the most number of transactions. You're now really interested in the state of things. Like,
Yes.
where are we queuing out?
Yes. What's happening? Like, metrics are great, but they're limited, right?
Right.
They're a snapshot. What you want to be is like, okay, when this happened, what else happened?
Right.
What else is connected to it? And like the old generation of tools are ones where you're capturing this data another time for every single tool. You're like, okay, here's my dashboards, the metrics, here's my logs, here's my traces. So every time you're like, I've got a spike, I want to find it in the logs, there's nothing that connects them.
Right.
You're just eyeballing timestamps and hoping that they happen to match up. And like, if you find it in the logs, you want to jump to a trace, like, that's not actually good enough. You can derive all of those data formats from these arbitrarily wide, from spans. You can't go in the other direction.
When you say spans, what exactly are you talking about there?
A span is a one hop of the trace.
Okay.
Across all of them. So should we be gathering spans all of
You
the
should be
time?
gathering telemetry, one event per request per service. All of the data should be aggregated into that one arbitrarily wide structured data blob, so that you have all that context. Like a really mature instrumented service will have like 200, 300 dimensions per hop.
Wow.
And that's magic, because you're passing along all of the parameters, you're passing along all of the IDs, you're passing along all of that context, which lets you, after the fact, come back and say, oh, this thing in this service that happened was connected to that thing in that service that happened.
Now, this is not necessarily at per transaction level. Like, you're not just chasing a transaction down. What's the...
It's based on
What
the
separates
parameters.
one span from another? Is it time?
It's well, typically, this is a complicated question.
Yeah.
There are lots of ways that you can define a span, but typically I like to think it about if you want to have a span around something that's interesting.
Right.
So like if it's anytime that you're crossing the network, you want a span.
Right.
Anytime you're taking a database request, you want a span. Because that's historically where problems happen. It's wherever you're crossing the
Right.
network.
So would you start at a user interface interaction and go from there, and then likewise for back-end services that go on timers?
Like you can have spans and tracing in monoliths too, and it's super, super useful there as well. But it becomes indispensable once you
When
have
stuff's
services.
distributed, right?
Yeah, because if you think about it, in the monolith, at least you have all that context, and it persists throughout the request. When you jump across the network from service to service,
You're deciding what state's going to come with and what
Exactly.
isn't.
So how do you do all this without bringing the server CPU to its knees? Do you do this typically the way we do it now is attached to background threads and that kind of stuff, but you can lose, if those threads hang, you can lose data.
There are lots of ways to do it. Obviously, I think that my service does it best.
Your service.
Honeycomb.io is what I work on.
So, well, you got to tell us about Honeycomb then.
Well,
Sure.
I'm not really great at pitching, but I will say that, like, the idea of how observability should happen is how we built our service, down to like the data store, like, because, like, rollback. How many of you ever built apps on Parse, the mobile backend as a service? No?
No parse people.
Wow.
Yeah.
I loved Parse so much.
Mm-hmm.
It was like Firebase, but better and earlier. Any Facebook people here? Okay, cool. I will have a
Nobody
grudge.
uses Facebook?
I will have a grudge against Mark Zuckerberg forever for what he did to Parse.
Oh my. Okay.
They shut it down. So we got acquired. Anytime you want to get acquired, make sure that you have an executive level sponsor who believes in your product.
Right.
Not.
Right.
So we got shut down, even though we were still growing like gangbusters. Anyway, Parse had 100 million apps by the time I left.
Wow.
And we had built our service originally on Ruby on Rails, which was not a terrible decision because most startups fail. It's usually not because of the technology that you choose.
And Ruby on Rails had the strength of you can move fast.
You can move fast. Sorry. It's just a...
That's all right. We bleep everything.
Yeah.
Okay, great.
Say whatever the you want. Doesn't matter.
Thank you. Ruby on Rails. The downside is it doesn't have threads.
Right.
Fixed pool of workers, right?
Yeah.
And so that was fine when we had 100,000 apps. But we got bigger and bigger, and instead of having one database in the back end, we now had 30, 40, 50. And when you've got that many, something's slow at any given time, which means that the fixed pool it's filling up constantly with threads that are waiting on that one back-end service that's slow.
Whatever grumpy service you got.
Boom. And like, as a reliability engineer, this was personally humiliating to me. You're going down every day. Just like an app would hit the top 10 on iTunes. Down goes Parse. It's like again and again. And I tried everything to try and figure this out. And what finally helped us was, number one, we did a rewrite to Golang. We actually considered using .NET, and it got outvoted. And I learned later that the blog post that I wrote about why it got outvoted made a lot of people at Microsoft very angry and changed a lot of their decisions, which is great.
Yeah.
Inspiring anger is really my career.
But I mean,
you made a career.
I have a tough time of disagreeing with you on picking Golang too. When you think about a back-end service at velocity, like
great.
that language is very well suited for that.
It was great, but it was half of the answer.
Right.
Because we also had to understand what was going on. Couldn't just write the code. We had to understand it.
This is observability learned in
This
blood.
is where observability came into play, because Facebook also had this service called Scuba, which was, don't get me wrong, but ugly, aggressively hostile to users. But it did one thing really well, which is it would let you slice and dice in near real time on dimensions of high cardinality. These wide events, right? High cardinality, for those who don't know, is the number of unique items in the set.
Right.
So if you've got a collection of 100 million users, any unique ID, like social security number for the US folks, would be the highest possible cardinality. Something like species equals human would be the lowest because there's only one, right? First name, last name, high cardinality, but there's some dupes, so it's not as high as social security number. So everything around metrics is oriented around low cardinality dimensions. But everything you want to use for debugging requires high cardinality dimensions. I see some people over here who have run into these limits before. So Scuba let us slice and dice on these high cardinality dimensions, and instead of having to Obscure and be like, either I created a dashboard for it, or it's going to take me hours to
sift it out,
dive through the logs and figure it out and everything. It's like, instead we'd be like, okay, we're getting a spike in errors. Let's break down by app ID. 1 in 10 million app IDs. Break down by that. Okay, now break down by error rates. Now break down by normalized database query. Now
are you making cube gestures or linear gestures?
These are columns.
They're columns.
Breaking down by column after column.
I'm trying to interpret for
and
the
it was
listener.
just like step by step. It would take me to. It's like it isn't even engineering anymore. It's like support. right? These problems went from being like intractable, like it would, I'm doing that again, from like it would take us a day to figure out and then it would never happen again, to just being like, 30 seconds, like every single time. And that was what, like, when I was leaving Facebook, I've never been one of those kids who's like, I want to start a company because I kind of hate those people. But when I was thinking about having to live without this tooling, I was like, I actually can't conceive of it. Like, it's become so core to how I perceive the world as an engineer. Like, I just can't imagine going back. And so that's why I made Honeycomb.
So how did the rest of the people in the organization react to this new culture of observability and span?
You know what's amazing? There's a learning curve, right? We've all spent our careers fitting our brain into asking questions in the metrics and dashboards type of way. But like, how every job I've ever had, the person who's best at debugging is always the person who's been there the longest. Mm-hmm. Always. That's no longer true when you have different tools.
Yeah.
Because instead of relying so much on what's in your head to reason about the system, it's right in front of you. And you're just asking questions, and it's more like the more curious you are, the more debugging you do, the better you get. You don't have to have the whole system in your head. You can find the answer more quickly that way.
Right.
And it's kind of a beautiful thing.
Yeah. Process of discovery too, right? Find exceptions.
That's why, like, observability is not just about, yes, you're going to have columnar store. Yes, you're going to have all these things in the back end that make it fast. Because the other thing about logging tools is, like, if you want to ask something interesting, it's like you enter the tool, you enter and then you're like, okay, I'm going to take 30 minutes and go out for coffee because it's going to, like, it has to be fast. It has to be interactive. It has to be like under a second because you're like, you're taking steps and you have to stay in the zone. Yeah, right?
You're pursuing an intuition.
Exactly. It has to be explorable. It has to be interactive, and it has to let you, I think most importantly, draw on the brains of the people around you. So something we built into Honeycomb is history. You know how you're debugging and it's like, oh, I've lost the thread.
Yeah. What was I looking for again?
So you can just go to that. You scroll back up. That's where I knew I had it, right? And you branch off and you try something else. But then also you have access to the history of everyone on your team. So if it's like last Thanksgiving, we had this terrible MySQL outage, and everything was shit. And Ben and Emily were on call, say. And then I'm on call in March. And I'm like, this feels a lot like what was happening last November.
Yeah.
I'm going to go and look at, like, well, what were Ben and Emily doing? And what did they say helped them find what did they star?
So also journaling.
Yeah.
The actions. Yeah. Especially the ones that get to results.
Because history doesn't repeat, but it rhymes, right?
Sure.
And so much of the wisdom of your, like, these are socio-technical systems. It's not just production. Like, an example I often use is, you've got the New York Times and the Washington Post. They're like both big newspapers, right?
Right.
But if you took their teams and swapped them, you couldn't actually do that because so much of the socio-technical system lives in the heads of the people who use it and write it. So, like, being able to draw on that wisdom and use it, like, it makes you a better engineer. Like, all of the shit that I learned about being a great engineer was looking over their shoulder of amazing engineers that I got to work with.
But it sounds like the journaling approach you're talking about allows us to look over the best engineers all the time.
Exactly.
Yeah. And get to, you don't have to remember how they did it because it's recorded there indelibly. And so, you can even learn their approach and how they tackle that particular kind of thing.
I feel like, especially nowadays when we're doing so much distributed working, like remote working, I worry a lot about how are we going to bring up the next generation of great engineers, And I hope that we're all starting to think about making this into more of our tooling. Just how can we learn from each other? It's kind of embarrassing, but like when I was in college, I learned so much from just going around and reading the bash histories of all the people I knew who knew their shit.
Just up arrowing.
just like paging through and like trying the commands,
What's that command?
It's fucking fascinating, right? Oh, that's how to learn set and awk, right?
Yeah.
I'm like, oh, what does this do? I think we need a lot more of that in our tools.
Yeah, and I worry that we're making it even harder to make that jump from junior to an intermediate. I mean, we've always had a problem with intermediates anyway.
Yeah.
But a lot of the automation tools that are taking a lot of
I know.
are eliminating the beginner stuff.
Yeah, like this whole like the generative AI stuff. Like, it's great for senior engineers. You're now so much more productive. You can code so much faster. But like the way that you get to that point is with scar tissue.
Yeah.
Yeah. Right.
How are we going to force ourselves? I mean, I believe that solutions will emerge. I hope,
Yes.
but it looks pretty bad.
Well,
right
and
now.
I also think that younger generation will find them too, because they are not.
Yeah.
We've done this show where we've talked about, is all this scar tissue actually holding us back?
Yeah,
Right, that we have instincts.
some of it.
Yeah,
Much-
some of it's
Not
valid.
all of it.
I think you have to internalize the damage and say, like, what does this really look like? And generally speaking, when someone says, "I will never use X product or X technique," it's like you have not internalized your scar as well.
Yeah, I love that.
Every team has to
That's
have
great.
at least one senior citizen, I think.
Yeah,
Yeah.
But also, can they learn to speak to, these are the concerns I have. When
yeah.
we think about the broader approaches to things that might have created that
I
problem
love that.
back in the past.
You know, I read this book called The Trauma of Everyday Life, which is written by this guy who's a psychiatrist and a Zen Buddhist, and he's talking about how trauma isn't necessarily something to be avoided because it's literally what shapes you. Think about a bonsai tree.
Sure.
That's just a normal fucking tree, but it was
Yep.
it was put in this very specific where its roots couldn't grow, right?
Yeah.
And so it's like not a recipe for like trauma is great, but it's also like their scar tissue is just going to be different.
Yeah. And again, how you react to it and how you work to it, you can make beautiful things.
So,
Exactly.
what are some of the other pitfalls that people will encounter when sort of moving to this observability methodology?
A big one is the cognitive, just the model that we have in our brain. I feel like our industry has avoided this for a long time, and I feel like there's a bit of a reckoning.
Mhm.
You know, OpenTelemetry, by the way, I got to put in a quick plug for OpenTelemetry
Sure.
here. It's amazing. I know all of us hate redoing our code, but like the promise of OpenTelemetry is you re-instrument your code once, and then vendors have to compete for your dollars based on being awesome instead of having you locked in.
Right.
It's the number 2 project after Kubernetes in the whatchamacallit.
CNCF. Yeah.
Thank you, CNCF. It's super active, a lot of contributors. I was pretty skeptical about this, but it's the way. I wish we had this 10 years ago. I think we'd all be in a
And the
better
crazy
place.
part is, we could have.
We could
We
have.
just
We
chose
could
to
have.
do it.
This is
Yeah.
a political problem, not a technical
Totally.
problem.
But we're there now.
But here we are. These are the tools that we have. OpenTelemetry is worth putting on your roadmap for the next year or two because there's also this reckoning that's happening with costs right now.
Mhm.
Most of these vendors are billing just like ungodly amounts of dollars that do not correspond to the value that you get out
Right.
of them because they can't.
Because they've got
you're
you
stuck.
locked.
Yeah, and so I feel like we need to take our power
Well,
back.
and it's a great pitch for a feature that's not necessarily a new feature. Is to say, hey, I can reduce our costs by moving us off this
Yes.
tool
Yes.
and onto OpenTelemetry.
You know, I'm going on so many sidebar rants here, but like I feel like learning to like one artifact of the zero interest rate period was that engineers forgot how to talk about our work in terms of dollars.
ROI. Yeah.
You know, because like dollars are the universal denominator. Maybe someday it'll be euros, I don't know, but like money is the universal denominator. And if we can't learn to talk about the value of the shit that we provide to people in finance, I feel like many VPs of engineering and CTOs have this phenomena where they feel like the junior partner at the table.
Right.
They aren't really invited to all of the critical meetings and stuff. And I believe that that's because we haven't learned to talk about the value that we bring and cost in the same language as every other team has.
Because if we did, we generate a lot of value.
So we generate all the fucking value. Every company is a technology company. We have all of the power we should need to have.
All we got to do is get a hand on it. And Sharon, I'm going to interrupt for one moment for this very important message. And we're back. It's .NET Rocks. I'm Richard Campbell. That's Carl Franklin.
Hey.
Talking to our friend Charity Majors about observability engineering and watching the sausage being made.
And so I want to follow up on you brought up generative AI and things. For programmers, it's great. For senior programmers who can be more productive with stuff they might have forgotten how to write or don't really care to figure out, and just let ChatGPT do it for you. But what do you think the future of observability is, especially in lieu of AI and where it's going? Do you think that we'll have AI bots sort of watching our telemetry and giving us English prompts, sending us text messages?
I think that vendors are going to sell CTOs and VPs like tens of millions of dollars worth of bullshit that says that they can do that.
Yeah.
Yes. Something that blew my mind when I became a CTO.
So wait a minute. Are you saying we don't need this? We have everything that we need right there in front of us?
No, I'm not saying that either.
Or?
Something that blew my mind when I came CTO, it took me a while to internalize, but that most executives have more trust and confidence in their vendor relationships than their employees. Because employees come and go, but vendors last forever.
As long as you keep paying them.
Blew my fucking mind.
Yeah.
But what they're selling when they come in, this is why my dander got raised so much by the whole AI ops thing. Because they were all just like, you don't need to understand your systems. Pay us all this money. We'll understand it for you. And but like the false positives are ridiculous and off the charts.
Yep.
All of the data is junk. You would be better off just like turning off all that data. Like it just so many problems with it. I believe that we should be looking to computers to do what computers do best and people to do what people do best. And computers crunch numbers. Yeah. People attach meaning to things.
Sure.
Like, your graphs are spiking all day long. Most of them you don't care about because our computers are now resilient to a whole lot of failures.
Sure.
It really takes a person coming along and going,
that's a bad
matters.
One. Yeah.
That matters, often because it mattered to another person. And you're the person who's there connecting those dots. And once you've decided it matters, you need to understand why. And I think there are all kinds of ways for computers to help us do that. We do this really cool thing called Bubble Up at Honeycomb, where any graph, any heat map that you've constructed, you draw a little bubble around something. You're like, I care about this. And then we compute the baseline for all the hundreds of dimensions and the dimensions that are inside the thing you care about, and then we diff them and sort them.
Right.
So it's like, okay, this thing you care about, here are the 5 to 10 ways it is different from everything that you don't care about. Computers are great at that.
Right.
But they can't tell you what to care about, and they shouldn't try because it's a fucking mess. Maybe 10 years from now, I will be eating my words, but for the foreseeable future, I really think that we're all best served if we focus on helping people understand what has meaning and letting computers take care of the rest.
Yeah. I mean, I can see the machine tools helping to point us to unusual events.
Hell yeah.
But you still have to interpret them.
Yeah.
Yeah. And
you want them to create that graph for you. You want them to intelligently sample often. You want them to do, but you don't want them in the business of telling you what matters.
No, they don't know.
They don't know.
And more saliently, like they're not even qualified to make that assessment in any way. That being said, like I gotta tell you, we're talking a lot of OLAP terms here, like a lot of data analytic terms around all of this, and machine learning models evolved from a lot of that technology. So you can see a shape of this shape of history.
You can see a shape, but I don't believe that it is one that. So here's the thing: at the bottom line, we are. Forget technology. We are held legally accountable. We are engineers. We are legally and ethically and morally accountable for the codes we put out into the world.
Right.
We can't point at an algorithm when it comes to that, even if it's in machine learning. I think
I don't know if you've read a EULA lately, but boy, oh boy, they work really hard to make sure we're not legally accountable for anything.
I believe in the near infinite possibility of lawyers. That's true.
Well, but certainly in the U.S.
I want to make sure that I understand what I put out into the world.
I like that we're also going to moral and ethical aspect, because I think that legal aspect's holding us back. That we can't own the value of what we make.
Say more about that.
That we can't own the value of a make as long as we're obligating our responsibilities to own it. Right? That really, the EULA was invented to allow us to not hold liability for the impact of our software. And so we're kind of in a trap, right? As an industry, if we were responsible for the damage we did, our employers would insist on higher standards because they're getting caught up in that as well. But because we've avoided that responsibility so thoroughly.
I see what you're saying.
That being said, like now we get into a pretty deep philosophical side on this thing. Like, let's face it, good telemetry, in the end, we're trying to understand why is the software behaving the way it's behaving? Why are our customers unhappy? Yeah. Right? I mean, those are the things that actually matter. I think the more often that we as technologists speak in the term of the customer,
I think you're
why
right.
are our customers unhappy?
And this is something I've been really grappling with lately. I don't know if I'm alone in this or not, but I have like an almost knee-jerk, almost disgust or like reaction to words like customer and value and things. And I've been trying to
because we've been battered with it.
Because we were what?
We've been battered with it.
Beaten up with those words. Yeah.
I don't know. Just the business aspect. Like, I think there's some vestiges of me that are still like, ew, we're better than that. And I hate myself as I'm saying that, you know? And it's
Because
something
you also open with the dollars matter.
they do.
And the
They do.
dollars kind of come from the customers.
Oh, you should have seen me 10 years ago, dude.
Okay, this is the chill version. I get that. Okay.
No, but you're absolutely right. We do this for the customer. We do this for our users.
Mhm.
That's the reason that we exist, and we have a responsibility to them.
Sure.
And I don't think I'll ever feel comfortable saying, "Well, the machine told me it was fine."
That's a cop-out every time. Because the machine didn't tell you anything. You interpreted it and chose to vocalize it. You know, in the end, everything we've talked about
We
never
programmed it to
did
tell us
not-
it was fine.
We're getting very philosophical.
But
here.
also, none of this described an action we should take.
yeah.
All we're doing is observing what's going on. We still have to decide on the action. How would you change the code, given you've seen this in telemetry?
And you know what else? Like, I feel like this loops back really nicely into just like what is the meaningful life, right? Like, because like that book that what's his face wrote about work and what makes us happy is it's not like having 20 hours a day, whatever, but it's like autonomy, mastery, and meaning.
Purpose, yeah.
And purpose.
Daniel Pink.
And Daniel Pink, thank you. And like the meaning, the purpose, that comes into play for us when it impacts other people.
Well, and you hit on the key thing, which is when we crack this nut, like every time you chase a problem down like that and it turns into a code change you can make that then in later testing shows that problem doesn't occur, boy, that's a good day.
That
Like,
feels so good.
you talk about purpose.
Yeah.
There's nothing better than
Nothing
figuring
better
that
than that.
complicated problem out, and then literally, like you live in a very hypothesis-based world. It's like, well, I've seen this telemetry, I've seen this output,
Yeah.
I believe it's this code problem.
Yeah.
Now I'm going to make a modification, I'm going to put it into the stream, and I'm going to go back and test again.
Yep.
And if I don't see it, then I can, hypothesize, really, because I might be wrong. We may not have recreated conditions perfectly, that we're on it, that we're pushing the right thing.
And nobody knows just how deep that went but you.
No. I also wonder, how many times have you been fighting a problem like that? And you start changing code just to see if you can change behavior at all. Like, am I even
Just
poking
as
in the
they-
right place?
Like, our systems they have emergent properties. They're
Yeah.
no longer, like, I feel like part of moving from, like, the old world to the new is to accept that TDD is not enough.
Interesting.
Like, tests tell you, will this logically execute?
Yeah.
But that reality ends at the border of your laptop.
Yes.
Right?
And the universe is weirder
The
than that.
universe is so much weirder than that. I feel like our jobs are not done until we've instrumented that code, deployed it, and watched it in production and asked ourselves, is it doing what I expected it to do? And does anything else look weird?
I know
Like,
that's
your
something I've
job-
said on the show before. I did a lot of load testing. It's like, I have never invented a load test as weird as customers on a
Nope.
Saturday.
That's where entropy comes from.
You can't even come close.
So
Customers are evil. Like, they do things you can't
They're brilliant.
imagine. Did that guy really open 6 windows and hit refresh all at the same time? Did he really? Really? Okay.
let me ask you some practical advice on behalf of the listeners. So let's say you're listening, you've been surfing, you went to honeycomb.io and you checked it out and you're thinking this might be good. How do you go back to how do these people in the audience go back to their teams and introduce this concept without getting flogged? How do you approach that?
Yeah, I mean, that's a great question. My approach is always to look for something that's really painful. Like, things that are going down that you don't understand.
Problem you can't crack.
Problem you can't crack.
And
things,
especially this siloed approach to telemetry that
things
we're
that are
doing now.
Things that are waking people up in the middle of the night.
Yeah.
We've seen this a lot where, people have tried to bring it in, whatever, but then there's an intractable problem and they put honeycomb on it and it's just like we've even had multiple times we've had our sales engineers doing demos on people's production systems
And find something.
You're about to have an outage here because this thing's happened. And they're like, what? And then 10 minutes later they get
Dunk.
paged. Because it is that, I know I'm a founder. Believe nothing I say, but it's that much easier when you have the right tools.
When you've had the right visibility.
Yeah.
Yeah. Just to be able to see what's going on.
Yeah, looking for something like that, or somewhat counterintuitively, the other side, another place we've seen a lot of success is people instrumenting their CI/CD pipelines.
Right.
Because if you instrument your CI/CD pipeline as a trace, you can see where all that time is going.
Yeah.
Yeah.
Yeah, that's kind of another approach to the model of what is the hard work here.
Yeah.
What's actually hurting us.
The struggle is only getting in the front door. We have zero churn. If the company didn't go out of business, they keep buying us. But it's difficult to get in the front door. But once we get inside, like, people
No,
usually buy
but I
us.
think you made the most compelling argument, and that's going to be tough for anyone in the room who's thinking about this. It's like, you have to go pick the largest dragon in the room and
It's like-
say, I think I could take that one on if
Yeah.
I had this lance.
Yeah.
Like, if I can get this lance and get it go, I'll go for the big guy.
Yeah.
And that's the kind of bet you need to make. But, the underlying part of this, because a lot of the software is already set up for the right telemetry, but it's the custom stuff we're building that's not. And how you provide good visibility into that.
Orienting it around, a lot of people also come to us when they start their open telemetry journey because we
Yeah.
have many of the world's best experts in OTel. So we could actually help consult as people are rolling that
What
out.
do I need to push onto the open telemetry stack that's going to help me, that's going to let these tools
Exactly.
understand what my app's doing?
Exactly.
Do any of you in the room have a question for Charity? Raise your hand. It's all right here. Phil Hack has a question.
So
Why don't you repeat the question?
the question is, that's a lot of data, and how does that cost? How does the cost get out? Does the cost not get out again? This is why. So on Twitter, I was joking the other week, and it kind of got out of control. I'm like, never write a database. No, really, never write a database. And I thought it was a very fun self-own because we wrote a database. People didn't understand that. So yeah, it's a fuckload of data. Like, we've got like 700 customers, and we run the combined production loads of all of them. It's like 2 billion events per second or something like that. And we give everyone 60 days of storage, basically for free. And the way that we do this, so it's a columnar store. So indexes are verboten for observability because indexes are a way of picking, I want this to run fast and nothing else to run fast. You want to be able to query on any of these dimensions. So it's a columnar store. And you're right. Like 2 years in, we ran into this, we're never going to be profitable because there's all these SSDs, all this RAM. And that's when this guy, brilliant engineer, I've been working, he was my first manager. His name is Ian. He's nowhere on the internet. He's amazing. He started looking into the cost models and did some tests. And so now actually, data comes in, hits the API, gets dropped into Kafka, then gets read off, onto, a pair of nodes, which are, as you would think, like lots of CPU, lots of RAM. But then after like 30 to 60 minutes, it gets tailed out to S3. The query planner actually runs via Lambda jobs. So the query planner comes in, forks out spans, and like, we thought it was going to be so much slower, like doing processing, from all these S3 buckets. It wasn't. It was different performance characteristics, but most queries still return with under a second. And S3 is dead cheap. So that's where most of the data is. And the Lambda jobs are pretty expensive. That's a big line item on our bill. So we've actually done some really great talks and written some great pieces about how we use Honeycomb to optimize our Lambda jobs so that the query
For
planner.
honeycombs?
Yeah.
Neat.
It's not recursive at all.
Yeah.
Yeah.
Our Honeycomb blog, by the way, is dope. Like, we don't do a lot of selling there. We just talk about a lot of engineering stuff, and it's pretty great.
There was another question back here first. Somebody back there had their hand up. Okay, it wasn't you, but go ahead.
So there's
Can you repeat the question? I'm sorry.
So the question, I think, was something about SLOs and metrics, and it's too expensive to store all the traces for all events. Okay. And there's a few different answers for this. I would probably want to ask you some more questions. Feel free to find me afterwards. But you're absolutely right. It can be absolutely cost prohibitive to store a trace for if you have a lot of traffic, because if you think about it, you might find yourself storing 5 to 30 times as much telemetry data as production traffic. Obviously, that's not tenable, right? The first solution that we usually steer people towards is intelligent sampling, which does not mean just like dumb sampling where you're like 1 out of every 10 you drop them. It means like we have a thing called refinery where there's a difference between head sampling and tail sampling, meaning sampling before you know what it is coming and after you know it's coming. So some of these things you sample after you know it's coming, so you can be sure and grab all of the slow events, right? Some of it is head sampling where you're just like, okay, for example, request their health checks that are 200s. This is junk. I don't need to store all of these.
Yeah, you don't
This
need
can be
those.
like a quarter of your traffic sometimes. So like sample them heavily. 200 OKs to the main page, sample them medium. Keep every request that's an error or every request that is to /payments or to billing or, like there's a lot of shit that is trash that you can like discard if you kind of go in there with a fine tooth comb. The part that was about SLOs, we derive SLOs from events, and it's actually really important that they're not derived from metrics. We are actually the only product out there that does SLOs the way they're supposed to be done per the Google SRE book, because other companies don't actually capture their data in a way that lets them do that. It's actually pretty dope. Like you have your SLOs, it tells you how quickly you're burning down the budget, and then it tells you what is different about the requests that are erroring, that are burning down the budget versus the others, so you can go fix them, blah, blah, blah. We also have a metrics, this is why I'm not sure if you're talking about a metrics product or just the events. But like the number one answer to the events being too expensive is you use smart sampling. And the number one answer to the SLOs is you want those badly. You can absolutely do sampling. So one of the things in every event that gets sent to us, there is a sample rate embedded in it. So everyone will say like 1/5, and that means compute this to be 5 like this. So the numbers all work out to look like they weren't sampled.
We got
Does
a
that make
question.
sense?
We got to move on. Question right in the front. Hello. Hang on. Can you repeat that with the mic?
The question was, obviously you can go wrong with logging because you can get way too many log events. You can go wrong with metrics because you can have famously like the $30,000 metric that had high cardinality in it, and oops, your budget. And so the question is, I think, well, how can you go wrong with observability? As distinct from those, and I want to say, even if you aren't doing traces, even if the most important thing to take away when it comes to telemetry is the magic of the one wide structured event per request per service. I actually found out years into this that this is how Amazon has done their telemetry all along. They have like a flat file at the root domain of every node where they keep one of these like wide. It's magic. It makes everything, because a lot of the logs that you are encountering, or because like when a request is executing through a service, it's just like boom, all these strings, right? But if you just like collapse them into one wide event with all of those keys and values, then you have that context, right? You can correlate
they're all
them.
together.
It's magic. So the number one thing that I think people get wrong with observability is not understanding that. That's the heart of everything. It isn't which tool you're using. It isn't whether you're tracing or not. It's that is the number one thing that everyone should be caring about. The number two thing I think comes out when dealing with spans, higher order problem. And that's because I feel like as an industry, we don't really have a set of like good conventions. You were asking me like, when should you have a span? Man, like I hope 5 years from now, everybody's like, well, obviously you should have a span when blah, 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 but we aren't there yet, right? And so it's really easy to either generate too many spans, and they get lost in the noise, kind of like with logs, or too few spans, and then not have the detail that you need when you need it.
Right in front.
The question is where to start with open telemetry. And there are only two good answers. One is my favorite, with the biggest pain, and if you have a really if you have a really resistant culture, then start with the least pain. But I actually think that the best way to roll anything that has to do with telemetry out is to kind of think of your attention like a headlamp. And if you're on call for something that's breaking, have an instruments first mentality. Like you instrument to figure out what's wrong, not you fuck around with your graph to find. Instrument, have it tell you the answer, and then it's there for the next time. You get paged again, instrument, you find the problem, and it's there. And as your headlamp kind of moves around the stack, within a couple months, most of the stuff that really matters will be instrumented, and then you can put it on the backlog to do the rest and finish up and get rid of your own vendors.
All right. Well, I think that's it. So let's give Charity Majors a big round of applause.
And we'll see you next time on .NET Rocks!
.NET Rocks is brought to you by Franklin's Net and produced by Plop Studios.
a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter bands by the FC